So in this video, I'm going to go through some calculations relating to binomial probability, and I'm going to do them in Excel. I'm going to use a slightly different method to the other binomial probability video, just to illustrate that there are multiple ways that you can get to the same final answer. So this question states a machine is producing bolts. It's known that when the machine is working correctly, 95% of the bolts produced are of sufficient quality, leaving 5% defective. So we're going to look at a sample of 20 bolts, which are randomly selected. And the first thing we're asked to do is find the probability distribution of X, where X is the number of defective bolts. Okay, so we're going to do this in Excel. So let's jump across. So what we're going to have is the first column of our probability distribution is a list of all the possible outcomes. So out of our sample of 20 bolts, the possible outcomes are either 0 bolts are defective, 1 bolt is defective, 2 bolts is defective, and so on. So we're going to call this X, and we'll list it out. So 0, 1, 2, 3, 4, and so on. I'm going to copy this down. So since we've got 20 bolts, the maximum number that can be defective are 20. And the second column is going to be the probability of that outcome actually happening. And for this, we have a couple of different ways to do it, but in this video, I'm going to use the binom dist function in Excel. So there's a few different things that we need to fill in. The first one is that we need to give Excel the number of successes. So we are saying that X, okay, is the number of defective bolts. We're going to treat this as the number of successes. So this first case, we're looking for 0 defective bolts or 0 successes. All right, the next thing is the number of trials. So this is equivalent to the number of bolts that we're taking out of our sample, taking out as a sample, I should say, and looking at whether they're actually defective or they're actually okay. So therefore, 20 is the number of trials. The next thing is the probability of success. So since we're treating a success as getting a defective bolt, the probability of that success or of getting a defective bolt is going to be 5%. That was given to us in the question. It told us that 5% of the bolts are defective. So writing that in a decimal, it's going to be 0.05. And the last thing we need to do is tell Excel whether we want a cumulative function. So cumulative basically means adding up a whole bunch of different numbers, accumulation. We don't really want that in this scenario, so we're going to put in false. All we're looking for is the probability of this one situation happening, of getting 0 bolts. So false, close the bracket, and that's all we've got. So this is telling us that for the event where we get 0 defective bolts in our sample, there's a probability of that happening of 0.35, or about 35% of the time. So I'm just going to put up here in brackets what these are. So this is the number of defective bolts in the sample. And this other one is the probability of, I'll put outcome occurring. So that number of bolts actually occurring in a random sample. Let me just wrap this so you can see it. Cool. All right, so we've done it for the first case. We've got the number of bolts that are defective and the probability of that happening. We should go through and do it for the rest of them. So you could go through and type out this formula, or if you want, you can drag it down and it should copy the formula for you. So as an example, if I look at this one, all right, it's now referring to the 6th case where we've got 6 defective bolts, and it's telling us that we have a probability of that occurring of like, oh, it's very, very small, about 0.03%, something like that, a very, very small chance. All right, so that's the first question answered. So the next question is looking at what is the probability of getting 2 or more defective bolts in the sample of 20? So 2 or more defective ones is the key here. So jumping back across, so the probability 2 or more defective bolts. It's what we're going to calculate. So there's a couple of different ways that we can do this. The first and probably easiest way is just to add up the probabilities of, this is 2 and more would be the rest of them. So all of these put together is going to be the total probability. So we can type that in as equals and sum to add them all up. And that's going to be the probability, so 0.26. Another way that we could do this is using the binom dist function. So if we go equals and go look it up in the list. So again, we need to fill it out. So the number of successes. So I'm going to select 1 for now. I'll tell you why in a minute. The next thing is the number of trials. So this doesn't really change. That's going to be 20 since we have 20 bolts. The probability of success, or the probability of a defective bolt, is still 0.05. And this is where it changes. So what we're looking for now is a cumulative distribution. We want the total of, 2 bolts being defective, 3, 4, 5, all the way up to 20. Okay, that's what cumulative means, an accumulation. So if you read what it says, so it's going to return the cumulative distribution function, which is the probability that there are at most number S successes. So this was what you put in the first thing here, A4, and I've selected 1. So if I select true here, this is going to calculate for me the probability that there is at most 1 defective bolt in my sample. So it's basically going to add together the probability of getting 0 bolts and the probability of getting 1 bolt. So let's do that for a moment. All right. So this is the probability of at most 1 bolt being defective. Now, you can see it hasn't returned the same value because it's not quite the same thing. So if we want the probability of 2 or more bolts being defective, using this other method, we'd need to do 1 minus this probability, and that would give us the probability of 2 or more. And then it's going to match this other one. So I guess that's a bit more of a complicated way of getting back to the same answer. So anyway, that's the answer for that one, 0.26 for here. Alright, so the last question, it asks us if the sample of 20 contains 2 defective bolts, would you suspect that the machine is working correctly? So what we need to look at here is the part B calculation that we just did. So the probability of 2 or more defects is equal to 0.26 or 26%. So what that's telling us is about a quarter of the time, assuming that this is what's happening, so 95% are good and 5% are defective, we are going to pick out 2 or more defective bolts in our sample, okay, of 20. So this is not particularly rare. All right, 1/4 of the time we're going to be picking 2 or more. So as a result, I would probably be suspecting that the machine is working correctly. So we could contrast this against a hypothetical example. If the probability of us getting 2 or more defects was a really, really small number, so say 1%, then probably I would conclude something slightly different, because then that would be quite a rare event, getting those 2 or more defects, in which case you probably do have sufficient evidence to say that, okay, in this case, probably the machine is not working particularly well. So that's pretty much all there is for this question, and I'll see you in another video.